Next, we have application of differentiation. Under application of differentiation, there are a few subtopics. Okay, the first subtopic that we learn is gradient of a curve. So how do we find gradient of a curve? Okay, so basically gradient of a curve is the value of first derivative when we substitute the x value. Okay, so based on that idea, okay, we also look at finding the gradient of tangent and also the gradient of normal. Okay, so the gradient of tangent is actually the gradient of the curve at certain point x. So, okay, let's say the gradient of tangent is m1. Okay, so if the gradient of normal is m2, and we know that the normal is perpendicular to the tangent. Okay, so therefore we know that m1 multiply m2 should be -1. Okay, so if we can know the gradient of tangent, which is m1, then we can find the m2 by finding the negative reciprocal of m1, and in that case we can find the gradient of normal. Okay, so based on that, we can use the gradient of tangent and the gradient of normal to find equation of tangent and equation of normal. Next, we learn how to find small change by using increments formula. There is a video about small change, so I am sure you have watched that video by now. If you forgot how to find small change using increments formula, you can always go and watch that video again. We also discuss about rate of change. So under the rate of change, we learn how to find average rate of change. Okay, so do you still remember how to find average rate of change? Okay, so if we want to find average rate of change, we can use this formula. Okay, so average rate of change is basically the rate of change over an interval. Okay, and so we also learn how to find instantaneous rate of change. Basically, instantaneous rate of change is the value of the first derivative at a certain point. Under rate of change, we also have marginal cost. So basically, marginal cost is the extra cost involved when we produce one more extra item at the stage of producing X item. Okay, so build on whatever we learn in increment formula. Okay, so we can actually find marginal cost by finding the first derivative. Okay, by substituting the x value in the first derivative, the value that we get will be the marginal cost. Okay, so the same concept applies to marginal revenue and marginal profit. After rate of change, okay, we learn about rectilinear motion. Okay, so under this subtopic, there are three very important terms that we must remember. That is displacement, velocity, and acceleration. Okay, so if we are given displacement function, we can find velocity by differentiating displacement function. Okay, and if we have velocity function, we can find acceleration by differentiating the velocity function, or we can find acceleration by differentiating displacement function 2 times. Okay, next we have second order differentiation and concavity. Okay, so we know that if we differentiate the first derivative one more time, we will get second derivative. Okay, so under this subtopic, okay, we learn about stationary point. Okay, so we know that stationary point happen when first derivative equals to 0. Okay, so if your first derivative equal to 0 and second derivative more than 0, then we will have minimum point. Okay, if first derivative equals 0, second derivative less than 0, then we will have maximum point. Okay, if both first and second derivative equals 0, okay, then it is possible to have horizontal inflection point, but further investigation is needed. Okay, so under this under the concept of stationary point, okay, we learn how to solve optimization problem. Okay, so we learn how to solve problem on maxima and minima. Okay, so next we have inflection point. Okay, so we learn that inflection point happen when there is a change of concavity. Okay, so if first derivative equals 0, second derivative equals 0, and there is concavity changes. Okay, so that means that point is a horizontal inflection point. Okay, however, if first derivative not 0, but second derivative equals 0, and there is concavity changes before that point and after that point, then there is oblique inflection point. We also learned that there is an exceptional case. Okay, exceptional case. So when first and second derivative equals 0 at certain x value, okay, so we have to do further investigation to verify that that point is a horizontal inflection point. Okay, so when we do the test, okay, and we realize that d2y dx2 are both positive, okay, before and after that point. Okay, we know that the shape of the curve is like this. Okay, both concave upwards. Okay, so let's say this is the point. So before that point, the curve is concave upward. After that point is concave upwards. Okay, because positive. Therefore, we will not have horizontal inflection point, but we will have minimum point. Okay, so we will have minimum point. Right. Okay, and then another case is if after we do the concavity test, okay, we realize that, okay, both before and after that point, okay, the curve is concave downwards. Okay, so concave downwards, then we say that that point is a maximum point. Okay. Okay, so based on the knowledge, okay, based on the knowledge about stationary point and inflection point, okay, we also learn how to sketch graph. Okay. Okay, so with that, we are done with the summary of differentiation. Okay, so this is the overall view about this chapter. Thank you. See you in class soon.